All right, in the last video, I defined these three trigonometric functions of an angle in terms of their ratios of side lengths in a right triangle. That sine was the opposite over the hypotenuse side, cosine was the length of the adjacent side divided by the length of the hypotenuse, and tangent was equal to the opposite side divided by the adjacent side. And our mnemonic device to remember this is just writing down the letters. S, sine, is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we just read that like they're words, SOHCAHTOA, and that's how we usually remember this. There are many other mnemonic devices if you want to look them up. I even heard once that you could remember this with some old hippie caught another hippie tripping on acid. You didn't hear it from me. All right, but let's put this to some good use. All right, so let's see if we can find the sine, cosine, and tangent of 30 degrees. So we learned last time that no matter what triangle in the world a 30-degree angle is in, that its opposite side divided by the hypotenuse was always going to be a half. So I'm just going to draw the triangle where the opposite side is equal to 1 and the hypotenuse is equal to 2. That could be 1 inch, 1 foot, 1 mile, doesn't really matter. We just know that whatever the opposite side is, the hypotenuse side has to be double that. Okay, so let's figure out, so we already know that the sine of 30 is equal to a half. Now, if I want to find the cosine of 30, I need to divide the adjacent side by the hypotenuse. I know the hypotenuse is 2, but I need to know what this adjacent side is. And to find that, we're just going to use the Pythagorean theorem. All right, so we know that a squared plus b squared is equal to c squared. Hypotenuse always has to go by itself on the side of that equation for the Pythagorean theorem. So this is a squared plus 1 equals 4. Subtract 1 from both sides. We get 3. And then I'm going to take the square root of both sides. And usually we put a plus or minus on that square root of 3. We're talking about the side length of a triangle, so we're just going to use the positive root. Okay, since negative doesn't make any sense in this case. All right, so that adjacent side is equal to the square root of 3. So we can say the cosine is adjacent over hypotenuse. It's going to be the square root of 3 divided by 2. All right, and that's always the cosine of 30. If you go into your scientific calculator and you type in cosine 30, it's going to give you 0.866 and change. That's exactly the same thing as the square root of 3 divided by 2. All right, and we have everything we need for tangent as well. See, opposite over adjacent. Our opposite side is 1. Our adjacent side is the square root of 3. All right, so there's our sine, cosine, and tangent. If you took trig in high school, it's possible that you were tortured by a teacher who said you could never leave square roots in denominators, and you would have been taught to rationalize the denominator and get this as the square root of 3 over 3. That's the same number. You can type them in on the calculator. They come out to the same thing. I'm fine with it if you want to rationalize a denominator. If you don't and you don't know what I'm talking about, don't worry about it. Calculus is full of fractions that have square roots in the denominator. I'm not really sure why some teachers get really up in arms about it, but just leave it as 1 over the square root of 3. It's fine. Okay, so there's one more angle that we can get out of this right triangle while we're at it. Okay, so I've got this triangle with a 30-degree angle. It's obviously got a 90-degree angle. So that actually leaves me with 60 degrees left over for that third angle. Remember that the 3 angles in a triangle have to add up to 180 degrees. So 90 plus 30 plus 60 is the 180. So we can actually get the sine, cosine, and tangent of 60 degrees out of this same triangle. So let's do that. This is a great time to pause the video and make sure that you're getting this idea. Make sure you get the same thing for sine, cosine, and tangent of 60 degrees that I will. All right. So sine is equal to opposite over hypotenuse. Now that we're talking about that 60-degree angle, the opposite side is going to be the square root of 3 because it's all relative to the angle that we're talking about. Okay, so opposite of 60 is root 3. But the hypotenuse is still equal to 2. Then cosine of 60 is going to be the adjacent side to 60. So the side that 60 is touching is that vertical side of 1. So adjacent over hypotenuse. It's going to be 1/2. And then tangent is opposite over adjacent. So now we're talking about the bottom side over the vertical side. So root 3 divided by 1, or just square root of 3. All right, so 30 and 60, they have this kind of relationship that their sine and cosine values are flip-flopped. Okay, so whereas sine of 30 is a half, cosine of 60 is equal to a half. And then they swap that √3/2 value for the other one. All right, so this is all we need to know for now for right triangle trigonometry. We're going to do a lot more with it in class.